Today we will discuss a new lecture using substitution method by trigonometric function. How to solve the integral by trigonometric substitution. We will use this type of solution usually when we have a radical expression in a certain way and a certain pattern of integration. So if we have a certain form of the radical expression, we will solve the integral by trigonometric substitution. In order to get rid of the radical expression, we will use the substitution method by trigonometric function. To clarify the idea, let's see this table. As we can see here, the form of radical expression under root a square minus x square. And if we have this form, the assumption will be x equal a multiplying sine theta. And after substitute the value of x in the radical expression, the value of radical expression, it will become a multiply cosine theta. And we will see how we will get this value later on. Let's see the second form, under root a square plus x square. The assumption, if we have this type of form of radical expression, then the assumption for x, it will be x equal a multiply tan theta. And after substitute this value of x in the radical expression, the value of radical expression, it will become a multiply sec theta. The third one, under root x square minus a square. If we have this type of form, then our assumption for x, it will be x equal a multiply sec theta. And after substitute this value of x in the radical expression, the radical expression result, it will become a multiply tan theta. For the moment, you just need to memorize the form of radical expression and the assumption. And this part, the value of this radical expression, you will see it in the example, how to get rid of the radical expression and how we will get this result. Anyway, so you need to memorize this form and the assumption. If you have this form of radical expression, then the assumption for x, it will be like this. And if you have this type of radical expression, then the assumption, it will be x equal a multiply tan theta. Let's see the other note. Now we will prove the value of these radical expressions. After substitute for the x value, this step is very important to understand how to obtain the value of the radical expression. Therefore, notice the following note. The first radical expression, a square minus x square. Notice that the form of radical expression is under root number square minus variable square. Number square minus variable square. Assumption, what is our assumption? It will be x equal a sine theta. Second step, then by substituting x value into the root, this is the radical expression. After substituting the value of x, we will get this result. And after opening square, we will get under root a square minus a square multiply sine square theta. This is after taking a as a common factor. The root will become a square all multiply 1 minus sine square theta. And this value, as we know from our previous lecture, it will become cosine square theta, because from cosine square plus sine square, it will be equal 1. And from this form, we will get this result. So this value, it will be equal cosine square. And after the simplification, the result of this radical expression, it will be equal a multiply cosine theta. So under root a square minus x square, it will be equal a cosine theta. Simple and easy. Let's see the second one. We have this radical expression. Notice that the form of this radical expression is under root number square plus variable square. Number square plus variable square. The first step, assumption. The assumption will be x equal a tan theta. If we have this type of form of radical expression, then our assumption will be directly x equal a multiply tan theta. By substituting the value into the root, we will get the following result. After putting the value of x in the root, we will get this result. After taking a as a common, it will be a square all multiply 1 plus tan square. And this value, it will be equal, this part, it will be equal sec square. Then the result it will be equal under root a square multiply sec square. After the simplification, we will get rid of the root. The expression will become a multiply sec theta. Then under root a square plus x square will be equal a multiply sec theta. Simple and easy. We have the last one, x square minus a square. Notice that the form of this radical expression is variable square minus number square. Variable square minus number square. If we have this type of form of radical expression, directly our assumption it will be x equal a multiply sec theta assumption. Then by substituting x value into the root, we will get the following result. After putting the x value to the root, we will get this result, and after taking a as a common, it will be a square or multiply sec square theta minus 1. This part it will be equal tan square, and a square we will keep it as it is. After making the simplification, the final result will be for the radical expression under root x square minus a square, it will be equal a multiply tan theta. Let's discuss another point, the most important famous relationship of a trigonometric function and right triangle. We have this is also important, you should memorize this formula. This is the right triangle. We have here adjacent, opposite, hypotenuse. For sine theta, it will be equal opposite divided by hypotenuse. For cosine theta, it will be equal adjacent divided by hypotenuse. For sine and cosine, notice that we have hypotenuse in the denominator. For tan and cotan theta, it will be tan theta it will be equal opposite divided by adjacent, and cotan theta it will be equal adjacent divided by opposite. This you should memorize these two, it is really important. It will help us to solve the integral in terms of x. Also, hypotenuse square it will be equal adjacent square plus opposite square. We have this also important. Sec theta it will be equal 1 cosine theta, and cosec theta it will be equal 1 sine theta. Let's see some practical example and the picture it will become more clear. We have this example. Find the integral of the following function. We have this function. We will find the integral for this one. How we will solve it? We will use the trigonometric substitution. Notice the radical expression under root 25 minus x squared will be equal under root 5 square minus x square. And this form of radical expression it will be similar to this form radical expression a square minus x square. So our assumption, if we have this type of form of radical expression, directly our assumption for x it will be x equal 5 multiply sine theta. This is the first step of our solution assumption. Second step, derivation. We will take the derivation for our assumption for the both sides. The derivative for x it will be dx, and the derivative for sine theta it will be 5 cosine theta d theta. And we will call this equation number 2. The third step, we will now substitute the x value in the root in order to get rid of it. We have this radical expression, and we will substitute the value of x. What is x? X it will be equal 5 multiply sine theta. After the substituting the value of x, open the bracket after the simplification. Now we will take the number 25 as a common factor. We will get this value. So it will be 25 all multiply 1 minus sine square, and 1 minus sine square, this part it will be equal cosine square. After making the simplification, so we will get this result 5 multiply cosine theta. So the root 25 minus x squared will be equal 5 multiply cosine theta, and we will call this equation number 3. The fourth step, substituting for the value, the root, and dx and x in the integral, which is mean that we will put the integral in terms of theta. And after making the simplification, we will get this result, integral 10 sine theta plus 1 d theta. So now the integral is become easy to find the solution. The integral for sine, it will be cosine, and the integral for 1 it will be theta plus the constant number. So the result of this integral for this function it will be this result. Notice the integration has been calculated in terms of theta. We need to put the result of the integration in terms of x, and we will do that through the assumption that we assume it from the beginning solution and the right triangle. In this case we need to find cosine theta and theta. How we will do that? We will do that from our first assumption. Our first assumption was x equal 5 sine theta. So sine theta it will be equal x divided by 5, and this it will be equal opposite divided by hypotenuse. As we know from the right triangle, this is the right triangle, and the opposite it will be equal x. This is the opposite, it will be x, and hypotenuse, this is hypotenuse, it will be equal 5. How we will find this part? As we know, hypotenuse square it will be equal adjacent square plus opposite square, and from this formula we can get this, the adjacent. So theta it will be equal inverse sine x divided by 5. We find this part. We already find this part. Now we will need to find cosine theta. As we know, cosine theta it will be equal adjacent divided by hypotenuse. Adjacent, what is the adjacent? It will be, this is the adjacent, it will be under root 25 minus x square, and hypotenuse, what is the value of hypotenuse? It will be 5. So cosine theta it will be equal this value. We only need just substitute the value of cosine theta and theta to put the integral in terms of x. So minus 10 cosine theta it will be this value, plus theta. What is theta? As we calculated, it will be inverse sine x divided 5 plus the constant number. And after the simplification we will get, this is the final result of this integral. Simple and easy. Let's go to see another example. Find the integral of the following function. How we will find the integral of this function? As we notice, we have radical expression, and this radical expression it is similar to this form of this radical expression. It is number square plus variable square. The assumption it will be a tan. So the radical expression 16 plus x square it will be equal under root 4 square plus x square, and this form it will be equal under root a square plus x square. Then we will follow the same step that did in the previous example. Our assumption it will be x equal 4 tan theta. We will call this equation number 1. Second step, derivation. We will take the derivation for both sides. dx it will be equal 4 sec square theta d theta, and we will call it equation number 2. Third step, now we will substitute the value of x in the root in order to get rid of it. We need to get rid of the radical expression. So under root 16 plus x squared it will be equal, we will just substitute the value of x, which is this value. It will be 4 multiply tan theta all square equal, after open the bracket we will get 16 plus 16 multiply tan square. After taking the 16 number as a common factor, it will be 16 all 1 plus tan square, and 1 plus tan square it will be sec square. And after the simplification we will get rid of the radical expression and we will have this value. So the radical expression 16 plus x square it will be equal 4 multiply sec theta, and we will call this equation number 3. Fourth step, substituting for the value the root dx and x in the integral. After putting the value of these in the integral, the integral it will become integral sec theta d theta. What is the integral of this one? As we learned from our previous lectures, the integral for sec it will be then sec theta plus tan theta plus the constant number. So the integral for this function it will be this result in term of theta. So we only need to put the integral in term of x from our assumption and from the right triangle. So we need to find sec theta and tan theta. What is our assumption? Our assumption from the first step, x equal 4 tan theta, and as we know tan theta it will be equal opposite divided by adjacent. In this case the opposite will be equal x, this is the opposite, it will be x, and adjacent will be 4 This is the adjacent will be for the hypotenuse, it will be under root 16 plus x square. In this case, sec theta will be equal 1 divided by cosine. It will be equal under root 16 plus x square divided by 4. Then sec theta will be equal this value. The last step, just we will put the result of the integral in term of x. This is the result of the integral in term of theta, ln sec theta plus tan theta. And this is the result after putting the integral in term of x, and this will be the final result. Simple and easy. Let's see another example. Find the integral of the following function. We will just follow the previous notes and everything will be fine. First step, we will take this, we will try to get rid of this radical expression. As we notice, this radical expression, x square minus 36, it will be equal x square minus 6 square. It will be equal under root x square minus a square. Variable square minus number square. If we have this type of form, then of the radical expression, then the assumption will be directly x it will be equal a sec theta, and a it will be 6. So x it will be equal 6 multiply sec theta, and we will call this equation number 1. Second step, we will take the derivation for our assumption x it will be dx, and the derivative for this it will be 6 multiply sec theta multiply tan theta d theta, and we will call this equation number 2. The third step, we will try to get rid of the radical expression. We just substitute the value of x in the radical expression, and after open the bracket, we will get this result, and after taking the number as a common factor, it will be 36 multiply sec square theta minus 1, and this value it will be equal tan square. And after the simplification, the final result for this radical expression it will be 6 multiply tan theta. So the value of this radical expression it will be this value, and we will call this equation number 3. The third step, we will just substitute equation number 1 and equation number 2 and equation number 3. We will put it in the integral. We will substitute the value for the root and x in the integral, and after putting the integral in term of theta, the integral will become integral 6 multiply tan square. Now, how we will find the integral for this? The numbers, we can put it outside the integral. So it will be equal 6 integral sec square theta minus 1 d theta. From the integral of properties, we will distribute it to the function, and the integral it will become integral sec square theta d theta minus integral 1 d theta. And the integral for sec square it will be tan, and don't forget the numbers, 6 minus what is the integral for this function, it will be theta, and multiply 6 plus the constant number. So the result of this integral in terms of theta it will be this value. The last step, we need to put the result of this integral in terms of x from our assumption. We need to find tan theta and we need to find theta. From our assumption, from the first step, it was x equals 6 multiply sec theta. So sec theta it will be equal x divided by 6, and this it will be equal 1 divided cosine theta. And as we know, cosine theta it will be equal adjacent divided by hypotenuse. So the adjacent it will be 6, and hypotenuse it will be x. Then the opposite it will be this value x under root x square minus 36. So theta it will be equal inverse cosine 6 divided x, and tan theta it will be equal under root x square minus 36 divided by 6. We get this value from the right triangle. We already find tan theta and we already find the angle theta. So we just substitute this value in the result of the integral to put the integral in terms of x, and it will be the final result of this integral. It is simple and easy. This is for today's lecture, and see you next time.